Welcome to EE World. I'm Martin Rowe. At the 2022 International Microwave Symposium in Denver, Colorado, we had a chance to visit the Rohde Schwarz booth, and you will see two parts to the following video. The first, Martin Lin will explain some of the measurements that the company does regarding 5G signals using a 67 gigahertz RF generator and a 50 gigahertz spectrum analyzer. Following that, Clinton Linville will give us a demonstration of the company's RF test chamber that's used to test over-the-air millimeter wave products, simply because millimeter wave's integration doesn't allow connecting devices to test equipment through cables and connectors, and we have to use over-the-air test chambers. Welcome to IMS 2022 here in Denver. I'm Martin Rowe with EE World, and we're in the Rohde Schwarz booth, and Martin Lim is going to explain to us some of their test equipment. What we've got here is a 67 gigahertz vector signal generator going into a 50 gigahertz spectrum analyzer. And Martin, why don't you explain some of the measurements that we can do here for 5G?
Sure, thank you. So as Martin said, this is a 67 gigahertz SMW generator. It has a full 2 gigahertz of bandwidth from the lowest frequency all the way up to 67 gigahertz. It is also overranged to go higher in frequency to 72 gigahertz. The nice thing about this box is this little unseen box, EVM optimization. This will fully calibrate the box in firmware so that we have the best possible signal, the flattest, IQ corrected, IQ balanced signal here. So we can be ensured that we're measuring the best possible performance. Here we have the spectrum analyzer, the FSW50, as you had said. It has a completely redesigned front end with 2 preamp stages and also an optimized mixer. And this allows us to have the best possible EVM and the widest bathtub curve. And of course, the wider the bathtub curve, the more usable range we have on our instrument.
Mm-hmm. So what kind of measurements are we looking at here?
Here we're looking at a 5G signal that happens to be 100 megahertz wide, and as you can see, it's 256 QAM. We decided actually to showcase some of the higher frequencies. So right now, we're at 39 gigahertz, which is a common 5G band.
Sure.
And as you can see, the EVM is at minus 45, give or take. I know it's a little bit below, which is exceedingly difficult to do with this instrument.
Now, EVM is a very important measurement, a very popular measurement. What is it about EVM that makes it so popular?
The nice thing about EVM is that it catches every possible RF impairment, IQ imbalance, noise floor, phase noise issues, flatness across your band. It's one catch-all that is able, with one number, you're actually able to capture a lot of RF impairments. So once you pass EVM, you're ensured that your part is doing exceptionally well.
And if you don't pass EVM?
Then you've got to do some research and figure out what the root cause is.
Okay, then you've got to go through and do each of the measurements individually.
Absolutely, absolutely.
Okay. Now let's go to the other side of the Rohde Schwarz booth at IMS 2022 and get a look inside the ATS 1800C antenna test range used for testing millimeter wave devices over the air.
Sure. Thanks, Martin. So what we have here is the ATS 1800C. This is our compact antenna test range. And if you take a look inside, we have several different features that we want to highlight. The first most important piece is the reflector. We have a parabolic reflector that is also matched with a feed antenna in the back of the chamber. And those pieces allow us to create a 30 centimeter quiet zone inside this test volume. So what we have is, we have an antenna that we're measuring a 28 gigahertz signal for 5G FR2, and the large quiet zone allows us to be able to test small or large devices and still have low measurement uncertainty. So the advantages of the compact antenna test range gives us a wide range of applications, from antenna design up to conformance test, and that's what we're demonstrating today, is how we can do 3D antenna pattern testing while still being able to do demodulation with our spectrum analyzer and signal generator.
Okay, so outside of the chamber we have the signal source, the RF signal source, and the spectrum analyzer, and they just feed into here. And we've got an antenna that's being used as a device under test just for today.
That is correct. So we can do a multitude of different types of devices. We have passive antennas like the standard gain horn, but we can also test antenna in package. So if we have some phased array that we want to measure, we can be feeding in a signal to that phased array and still perform the same measurements. So we can use vector network analyzers if we're doing just a purely passive S21 type of measurement, or we can use the spec and SIGGEN if we want to make modulated measurements.
Okay. Now it looks like that you can the DUT that's spinning around looks like it can also rotate. Like the entire foam there can rotate. It looks like, is that also the case?
That is the case.
Does that rotate automatically?
So with the positioning system inside the ATS 1800C, we can control that manually via web GUI, but we also have automation software that can control the positioner and set different angles of arrival for the signal. And this also controls our measurement instruments. So the automation software can control the entire test and give users feedback on the radiation pattern as well as some of the performance metrics like EVM or ACLR if they're doing modulated measurements.
Okay, now you've got on this chamber, let me back up a little bit. You've got hinges on this chamber on the side. Now, are those for doors or so that you can approach it from any of three sides, or is there another reason for having all those hinges?
So this chamber, this is the newer version of our ATS 1800C. We can configure this to have a solid wall on both sides, so it's a single reflector design, but we also have two additional side chambers that we can configure so we can have a total of 4 angles of arrival for FR2 signals or anything that's out of band. So we have a picture on the other side of the wall if we want to take a look at that, and that'll show what the configuration looks like as what we call the ATS 1800M for the multi-reflector design.